Welcome back to the mountain bike build series. This week, I'm preparing the head tube and the seat tube by machining them with these guys so that they will fit the headset bearings and the seat post. Let's get into it. Once we get this thing painted and we start assembling it, we need a good fit for all the different components. And when it comes to the head tube, what we'll do is we'll use a headset press and we'll press in these aluminum cups. The aluminum cups hold the bearings, and then the bearings provide that smooth and tight steering action with the fork and the handlebars, all that crap. And so in order for those aluminum cups to press in just right, you need the right fit here. And the way they make and sell these head tubes, and the way that you would make it if you're making it yourself, is you would start undersize. You do all the fabrication, you do the welding, and then after you were done with all the hot work and the welding, then you would come in with one of these guys. And this is a head tube reamer facer, and what you do is you cut this so that it has exactly the right size bore and it's exactly the right diameter. It's perfectly round, and then you also want to square up this top face and this bottom face so they're totally parallel with each other. And so if you didn't do that, you know, your bearings wouldn't fit as good, they maybe wouldn't be aligned right, and then your bearings wouldn't feel as silky smooth, and they maybe wouldn't last as long if you could even get them to fit in the first place. And so Park Tool Company and some other companies make these, just manually operated machining cutters. And so they're pretty expensive. I think this one retails for about $500, and it comes with maybe like 2 or 3 different size cutters. And they're, when I bought it anyway, there were cutters for like old school bikes, you know, like the quill stem 1-inch threaded, forks and maybe 1 1/8. Well, this is a 44mm head tube, so you got to buy other cutters. And even this part of it doesn't really work, and so I have a workaround for that. But it's pretty simple when you have the right cutters, and I'm going to walk you through how you go about doing it with success. So the first thing you want to do is make sure you have the right size cutters. And this is a reamer facer, right? Reaming is where you use one of these guys, and that opens up the bore. Reamers are really good at bringing stuff to a precision size and very round. Whereas like if you just drill with a drill bit into material, for instance, it's not actually that round, and it's hard to hold sizes very consistent. Reamers are, in lots of different applications, really good at roundness and particular diameters. And so that's why we're going to use a reamer, because this is already almost the right size. This brings us the rest of the way. And then this one is a facer. And the facer touches the top face, and then we'll do the top side, and then we'll pull it out and we'll do the bottom side. And so the facer just ensures that the top edge and the bottom edge are square to each other. And so we want both reaming and we want facing, and so this will do them at the same time. And so this is like an extra large facer that Park Tool sells for their cutter, and it's a pretty expensive piece. It's over $100, I think, just for this one cutter. And this will do monster head tubes, and you can use it on some bottom bracket shells as well. And then this cutter here is like 33.95mm in diameter, or whatever it is. It's for this particular 44mm headset. It's a nominal size. We call it 44mm, and there's a particular spec for exactly how big that's supposed to be on the bore, plus or minus whatever. And so Park Tool just sells you this reamer, and from my experience, it works great. They've done the engineering for me with the Cane Creek headsets that I usually push in. Fits great. And so I had to actually machine this little aluminum spacer between the two of them. I turned that on my lathe a couple years ago, the first time I used this, so that it would get deep enough down into the head tube to clean up everything. And then this nut holds them on, so if you want to switch these cutters, you got to back off this nut. On the other end, you've got a really cool piece they've designed. It's a cool idea. There's some issues with it. I know you can pinch your finger in this if you're not careful, but you press in on this, and that disengages the nut, and you can slide it, and then wherever it is, you can turn it, and it spins on the Acme thread. There's a spring here for preload, and then the idea is that this cone, when you have it in there, the cone is supposed to guide you so that the other end of it stays center, and so that this rod is supposed to be like axially centered in the tube. It's supposed to run straight down the axis of the tube in the center, parallel to the tube, and so this cone helps you stay centered. Well, the issue is the cone doesn't get to a large enough diameter, and so it doesn't work in this case, and I had to make another part to make this all work out. So this guy is like a pilot sort of thing. It's a pretty simple part to make on a lathe, and I think they sell an oversized cone that you can swap on here actually, but you know, this fits and it'll keep it centered up. So the only issue is that this spring preload thing doesn't work, and so you have to constantly adjust the tension manually, but it's not something that I can't manage to do. And so we're gonna machine the top and then the bottom. This here is the Spillmaster cup. I love these cups, and I just use an acid brush and this with this is Relton Rapid Tap, and there's a bunch of different cutting oils you could use, but I like this stuff. It's thick, it's good for steels. If you're doing titanium, you want to make sure you're using a cutting oil that's particularly good for titanium. And I forget, I haven't cut titanium very much. I forget there's certain ingredients in cutting oils that are better and worse for different materials. If I was cutting aluminum, which I'm not, I would use WD-40, and Relton Rapid Tap works pretty nicely for steels. Now, you need to be careful with this because the cutters are expensive and you don't want to damage them. So I'm going to be real gentle as I assemble this. And you just want to make sure that you always spin the cutter in the clockwise direction that it's intended to cut. You never want to spin it backwards. That'll wear out your reamers super quick. And so you just, even when you go to remove it later, you want to keep spinning it forward. And so it would work better if I could adjust the spring preload, but I can't. I could machine a different part, but this will work. I'm actually going to put some more, before I cut much, I'm going to put some more cutting oil in here. Too much isn't going to hurt. Might be a little bit messy, but we need to, you know, degrease and clean the frame before we do the paint work anyhow. So I've worked the reamer all the way into the bore to where the facer is starting to make contact. So how far do you face down, right? That's the question. Well, you can see that this is all cleaned up, and then right here on the back, that's not totally cleaned up, which makes sense because you can see it's so close to the weld. You know, it's distorted a little bit from the heat of the welding. So I'm just going to face down a little bit further until I get a full cleanup, as I call it, and then we'll flip everything around and just do the same to the bottom side. The idea is to take off the minimum amount necessary, and you know, I think a lot of people, when they're building bikes, they'll leave the, you know, if they're cutting the head tube from raw stock, they'll start with something that's like 1 millimeter or 0.5 millimeter long or something like that. Millimeter is like 39,000ths of an inch, you know, so just a little bit of material that you're taking off with the facing just to bring it into squareness. Just a bunch of chips in here I'm going to blow out. There we go, that's a full cleanup. And I can flip it over and do the same on the other side. I got most of a full cleanup. I think I can see just a little bit right here, maybe that's not. So I'm going to come in and just do a tiny bit more. The reamer, or the facer actually, leaves just a little bit of a burr on the outside. It's a pain in the butt to handle, so I'm just going to take that burr off with some Scotch-Brite. So yeah, it looks pretty good. The faces are you know, parallel to each other, and I know that because the tool was rotating and it was pretty dang parallel to the central axis of this tube. So I know these ends are pretty well parallel to each other. You can get some chatter on the surface doing it by hand, especially having that spring helps, and the way that I have it set up with that homebrew pilot bushing, you don't get that spring pressure. But this is still looking pretty clean. And then here, you know, this is a different operation, the reaming of the bore, and you can see that it came all the way down to right there, and that sharp edge there is where it stops. And that's definitely deep enough for the headset cups that I want to press in, and it's a nice cleanup. And if you look around it, you can see that it's a fairly even amount of metal removal, and that it's shiny metal all the way around. It did get a full cleanup. If you have a super ovalized or, you know, distorted head tube from the welding, you can have it so that it doesn't even fully clean up all the way way around. Titanium especially is known for really distorting roundness when you weld it. And I haven't machined any titanium head tubes, but you know, you're always kind of looking for that full cleanup so that when you press the aluminum cup in, you get a nice fit with full contact all the way around. So right here we got the seat tube, and the bore of the seat tube is nominally 31.6. You know, nominally it's called that. Well, it's a little more technical than just saying 31.6. Our seat post is 31.6 millimeters nominally, and so these need to fit together. And if they were both exactly 31.6 millimeters, there'd be it would be a little bit tight, I think. And so realistically, the bore of this should probably be a little bit bigger than the seat post. And I don't know if there's like a spec that the different manufacturers agree on for seat post diameter. I measure this one and it's about like you know, 0.05 of a millimeter undersize. And so I don't know if that means that the bore of this ought to be 31.6 exactly. I guess I haven't seen a spec anywhere, but if you look in the SRAM and Shimano frame fit PDF documents, that's maybe in there. Anyhow, this is the seat post I'm going to use, and so I'm going to make these fit nicely against each other. This is a tool that I can use to help me establish what size this is. You know, you have calipers here, and these are great, but when it comes to measuring a bore, they're just not the best tool for the job if you want a good reading. You can only read right at the end, and it requires you know, a really specific kind of feel to read the right number. One of these guys, the telescoping bore gauge, is useful. You kind of spring it together, you open it up, you tilt it a little bit, you tighten it up, and then as you sweep it, you know, it finds the apex of the tube and it springs down just enough, and then you can measure the outside of that. And so it looks like I'm just a little bit undersized. I'm actually very, very close to the size that the seat post is. And I've done a number of readings, and it's pretty repeated through there. I'm pretty close to that number. Now, I have my adjustable reamer, and I kind of hate these. You know, it's a pretty affordable option. You can get this for about 35 bucks from MSC Direct, and there's all different places that have these. You loosen this nut, and then all of these blades can slide this way on the shank of the tool, and you see these grooves here are sort of like tapered, or you know, there's an angle to them. So as you slide these knives closer to the top of the tool, and then, you know, you tighten up this nut, then the tool effectively cuts a larger diameter. And if you want it to cut smaller, you move them in the other direction. So it's loosening and tightening these two nuts. We'll slide them along the length of it to change the cutting diameter. And then you can measure it with calipers, and you can get a sense of how big this is. So this should be cutting about on size, and I just left this where it was the last time I did a 31.6 seat tube, and I know that that one ended up fitting all right. So there's a risk here that you blow your tolerance and you cut it way too big and you scrap the frame. I don't think that's going to happen here. You could sneak up on it. What really works better than an adjustable reamer, though, is to have a dedicated size helical reamer. So where this has straight cutting edges, if you had already slotted the seat tube for that pinching action of the seat collar, you could hang up the little, on the cut there, it could snag against here. If you have a helical reamer with the helical cutting edges, then it tends to not snag that, which is nice. And I think it also leaves a smoother finish than the straight shank. But this is very cheap, and this is what I have. So I think, you know, a good helical reamer is a couple $100 for a, you know, to an odd size like 31.6. Only the bike industry cares about 31.6. Nobody else is really doing that that I know of. And actually, a tip that I got from Jeff Buchholz at Sputnik Tool is that you can get a 1 1/4 inch reamer, which is just a hair over 31.6 millimeters, and you could send it out to a sharpening, like a tool sharpening expert or whatever, tool sharpening shop, and they can grind it down to 31.6 if you want them to. And that's probably the way that I would go if I was going to build many bikes. I would definitely do that. I would look on eBay and I'd find a nice quality high-speed steel helical reamer, and I'd buy it, you know, 1 1/4 inch size, and I'd send it out to a shop and I'd get it ground down. So anyway, what I'm going to do is put all the cutting oil on here, and I'm going to feed this in. I made the handle for this just so you get lots of leverage. I think I saw Drew at Engin Cycles made handles like this for his reamers, because when you're cutting the seat tube for a titanium bike, it is a bear to do that. It is a huge job, and it sucks. Apparently, it's like a huge workout to ream those out. And so you put long handles on, and people will put like mountain bike grips on there and stuff, just because you spend so much time cranking away at it if you do it manually. So I think this is set where I want it. I've tried the fit, and I feel confident going ahead with this. So I'm just going to lube this baby up. I'm using the same cutting oil. Again, you always want to turn clockwise. These cutting edges, maybe on camera you can't see it, but they are ground to cut on the right-hand side here, or my right-hand side. And if you spin them backwards, you're just going to dull them in a hurry. So I want to be real careful as I start this to be feeling a lot about what feels like it's going in straight. I don't want to push it crooked. If you had it in real crooked, you would be kind of biting on the outside edge, and it would... You could wallow it out and make it so that it was, maybe in the middle of it, it's more your size, but there could be like an hourglass shape or something if you don't follow it in straight. So I'm just trying to be real gentle and aware of the way that it feels. As you're cutting, you'll feel that this warms up from the friction of it, and so it's something to be aware of. This is pretty cool right now, it's not a problem, but heat can damage and degrade things. I don't think you're going to get it so hot from cutting by hand, but if you just put like a drill on here or something and started spinning it at 1,000 RPM or something, first of all, you probably get yourself into trouble in a hurry. Second of all, it would get hot and you could dull the cutter faster, and there's a lot of reasons why. If you have a machine set up to do this, like a lot of builders will get a lathe, like an old lathe or something set up just for these kinds of operations, you want to spin it at the slowest RPM you possibly can, like under 50 RPM is best. You don't need a very heavy machine to do it, and so the smaller lathes tend to spin, their low speed tends to be faster, but if you get it set up, you want to spin it really pretty slow. I think is going to make the cutters last nice and long, give them a nice long life, and give you a little more control over the process. Now when it comes to the depth, if you'll remember, we welded in a seat collar up here. That's really the only part that it can cut. The rest of this, the inside diameter of the tube, is bigger than this reamer diameter anyhow. So all I'm doing is feeding it in to the depth where it pokes through the backside, and then I want to keep pushing because I want to average it out. Like these different blades are maybe not all perfectly at the right diameter, so I want to get the front edge of the cutting blades or whatever, I want to get them past this seat collar, and then I want to take it an inch or so past that. It should cut pretty easy at that point. And then, while continuing to spin it clockwise, I'll pull it back out again. Part of the situation here is that the heat from welding distorts things, and then if you have like a full penetration so that there's any of this weld alloy on the inside, it can be hard there where you're cutting in those weld spots. It doesn't want to cut through the welded areas, and so what can happen is you can get situations where it specifically doesn't want to cut round. Whereas reamers are known for cutting nice round bores, you can actually get a situation where if this isn't sharp enough, I think it wants to walk around, and it wants to like flex the tube out of the way to avoid cutting the harder material. Instead, it digs more into the soft material. I don't say that from a lot of personal experience, but I've heard people say that, and it makes sense to me that could happen. And certainly, I haven't had the best luck with these reamers getting like super nice, round, accurate, consistent bores. It seems like they walk around a little bit, and they don't make the best fit. It's like I'm the captain of the ship, and the gentleman up in the crow's nest has told me, "Captain, there's this iceberg ahead, hard right." So now that I've cut past the bottom of the seat collar, it just kind of feeds in pretty easily, and I just want to pass it through there with a couple rotations, just kind of easily feed it through there, and it'll clean up whatever and average itself out. And then I back it out again. So at first it was taking a lot of cut pressure to move, and then all of a sudden it got easy, and that's because I got through that smaller diameter. Now I'm going to pull it out again. Still spinning clockwise. I'm really interested now. How does it fit? So I mean, there's a little bit of effort. to keep sliding it in. You know, it's just a little bit tight. Let's pull this out. Am I zigzagging it? Am I leaving marks? Well, no, it wasn't enough to chew up the surface of this. So it's not scratching that hard, but it's just a little bit tight down in there. So I might open up the reamer just a little bit and take a little bit more of a cut. It's a little hard to take a measurement on this because you need to be totally square with the blades and you need to be sort of on the apex. It's like there's like two axes in which you need to be right on the money in order to take a measurement. It's pretty difficult. Before I was measuring just about 31.6 across most of these. Here it looks like it's a little bit higher. And I don't imagine it's totally consistent across the length of the tool. So I'm going to back this nut off just a little bit, and then I'm going to tighten this one back up again and take some more measurements and see how much it moved. That's a much better fit. I could take a little bit more off. I don't think I want to. I'm going to try doing the next step and see what happens. So this is a flex hone. They use these in a lot of industries. Like if you're rebuilding an engine and you're boring and polishing the cylinders, you would use these. I should maybe get a new one. This one's got a lot of use on it. But you spin it in there. This is a polishing tool. The reamer is a cutting tool, and the idea with the reamer is that it goes into a bore, and the bore might kind of snake around, and it might not be totally round, and the reamer should, if it's sharp and if it's accurately ground and stuff, the reamer should cut off the high spots, and it should average the bore into a nice, very cylindrical, you know, perfect bore. It should be right on size. It should be pretty straight. And so that's what the reamer does, but it doesn't necessarily leave the smoothest finish or anything. And so the idea with the flex hone is it comes in and it polishes after that cutting has happened. It's supposed to, you know, make it real smooth and slide nice, and like the opening here has got a little bit of a burr. And so this is like a common bike shop tool. A lot of bike shops wouldn't have a seat tube reamer, but they'd have a flex hone. And so you can't really flex hone this into fitting. Like, it's not quite enough. If you TIG welded a frame together, you got to run a reamer through there pretty much always. But the flex hone can help. You know, if you have it in there long enough, you can open things up maybe a little bit, but really it's more of a polishing tool, and it's a nice step to do after you ream it. And you see this one, there's supposed to be spring tension enough to have pressure out on the bore, and this one is just not quite tight enough, so I'm kind of like manually doing this number, which is not really the way to do it. You'd like to have one that goes in a little bit tight, but you know, it's what I got. So let's try this again. Now that we've used the flex hone to kind of polish it out. You know, it's just a little bit sticky. It's not bad. It's not scratching up the seat post, and it's certainly free enough that you can adjust it. I guess I would maybe go a little bit bigger yet, but I'm afraid that what would happen is that this reamer maybe doesn't cut a perfect bore anyhow, and so what I'm afraid of is that I open it up more where I don't need it opened up more, and I don't do a whole lot to the areas that have constricted the most from welding. That's what I'm afraid of. Because it works and because I don't want it to end up sloppy, I'm just going to leave it where it is. If down the road I ever get a nicer reamer, I can always, you know, take out the seat post and run it in there, but you can't really put the material back. You could use a shim. If you totally dipped it over, you could ream it bigger, and then you could use, you know, a thin shim or something, but I want to avoid that, so I'm just going to leave it where it is and move on to slotting it for the pinching action of the seat collar. So it's kind of dark back here, but I went ahead and I got the bike frame set up on this special tool that I have, so that then I can use this slitting saw to make the slot for the pinching action of the seat collar on the frame. And so the way this works is this tool goes in the vise and it creates a flat plane above the table, so you don't need to take the vise off. And then it has these clamps, and I was a chicken, so I added some extra clamps. It's all in the name of getting this slitting saw to make our slot for the pinching action of the seat collar that's going to go on here. And this is all based on something I've seen in photos from the Engin Cycles shop. Drew Guldalian, Engin Cycles, he's in Philadelphia, makes beautiful frames. And And I actually had him on the podcast this last week. We talked some about, you know, his how he's always documented and showed lots of his process, and I thanked him for that because that was always helpful to me when I was trying to figure out how to do stuff. I'd look at pictures of how he was doing it, and that would always give me ideas for things. So I built this tool based on something that he does. He uses a slitting saw like this to do the C-tube slotting. And so what we have here is like a 4-inch or so slitting saw on a slitting saw arbor, and it's in the Bridgeport. And this is I think 1/8 of an inch wide, which is about 3 millimeters, and it has square corners on it. This is something that I just like it came with the machine or something, and it works. What you would really like to have is what's called a full radius cutter, and so that would actually have, instead of square cornered teeth, it would have rounded teeth. That's what you want. I don't have that, so what I'm going to do is I'm going to bang a slot in here, and then I'm going to have to use little hand files to round out the bottom of it, which is an extra step. But, you know, I was a cheapskate. Last time I was shopping for these, I saw they were like 130 or 150 bucks. And so I was just waiting for when I would see one on eBay, you know, for next to nothing, just some old used one. And that day never came. I never got one. So I'm going to have to use a little small little file to round out the bottom of the slot. So what we have set up here is I'm going to put the slot on this front edge. The slot's going to go right here, and I want it to be, I don't know, 3/4 of the length from the top to the bottom. I don't know exactly what's ideal, so I'm just going to eyeball it based on what looks good. So one of the first things that I did once I got it set up, and I made sure that these clamps were going to clear. You can see that these kind of get in the way, but they should clear. I just wanted to, you know, these toggle clamps hold it down, but I put on these extra C clamps because I was afraid you really don't want this to slide out of position or bite in the middle of the cut. So I was a chicken, and I put some extra clamps on there. With these Paragon Machine Works tubing blocks, now it's really quite rigid. It's held quite well, and I feel better about that. This cutter, we want to bring it to the right depth, right? It's that game show thing again. We got to get the right depth. And so what I'm doing, this is easy for me. I have this Mitutoyo Quill digital readout. These are sweet. Mitutoyo is like the name brand, and this is like, I don't know if this retails for 300 bucks. You can get cheaper import ones for as little as like $50 or $80, I think, and they're probably fine, but this was on sale, and I really wanted it, and so I bought it, and it's awesome. And so what I'm going to do is I'm just going to bring it down until the face of, you know, one of these flanks or whatever of the cutting edges touches the top of my seat tube. So I bring it down until it touches, and then I can zero this, right? I'm touching, it's zeroed, and now I can do some math. I know that this is 1/8 of an inch thick, and I know that the seat tube is 1 3/8 of an inch, and so I think, my mental math is that I need to drop this 3/4 of an inch, because you take the total diameter of the seat tube and the total width of the cutter, and what you really want to do is move half of both of those down. And so I'm going to move off of the cut, and also I'll show you, before I do that, I'll show you that on the digital readout there, those numbers actually relate to the ending position that I want. So I'm going to bring in the cut nice and slow to make sure that I don't accidentally cut something I'm not supposed to. But in the process of bringing that cut in, I've set my 0 points here based on roughly where I want to end up. And so that's going to help me a little bit as I'm feeding in to get where I want to go. So I'm on the center line here. I brought it down. You can read the digital readout now. We're minus 750, and it looks like it's on center. I'm satisfied with that. And so there's a couple notes about this. I want to use the Relton Rapid Tap cutting oil. Just liberally apply it to this while we're running. And I want to be running at the slowest speed that the machine can. I mean, partly because you get a mechanical gear reduction and you have more torque. Maybe that's relevant, but especially just to save the cutter. As it spins faster, it generates more heat doing the same cut, and you know, I want this to last a good and long time, so I don't want to burn it up, right? And so when you're calculating your cutting speeds for things, you have like surface footage per minute, or you know, if you weren't using inches and feet, and you know, if you weren't using the standard system, it's the same idea. As your cutter gets larger, the same RPM makes the outside diameter of the cutter, like the cutting teeth, it makes that spin faster, right? Just like big wheels versus small wheels at the same RPM. And so I want to spin this pretty slow, and if I look at my speed chart, my slowest speed is 80 RPM. That's plenty fast. I'm not in a speed race to get this thing done, so I have it all the way in low speed here, pretty slow, The other thing that you want to keep in mind is on an old manual milling machine like this, you have climb cutting and you have conventional cutting. And you can think of it as just like, as your cutter is cutting along the surface, and then you're moving relative to the surface, are the cutting teeth like, is it like clawing itself along? Or are you pushing it in the other direction where you're pushing the cutters against the direction that you're feeding? If your cutting teeth are sort of like pulling themselves along, that's what you call climb cutting. And you always need to be careful with that and try to avoid that on these old machines, especially with a big cutter like this. Because if there's any slop in the machine and it wants to pull in the direction of the cut, it can just start feeding itself, and it can be like a runaway train, and it can be bad news. And so it doesn't always do that, but it's possible. So whenever you can, you want to try to push into the cut rather than let it feed itself. And so in this case, it's got a little bit of a climb cut, so I'm going to try and feed the table mostly in the x-axis rather than in the y-axis, and I think that'll make it go a little bit more smoothly. Other than that, I think I'm ready to start making the cut here. I'm just going to nibble my way in. So right now, I've cut to my 0, point that I established. I just figured that out before I had it drop down and it was sitting above. I just kind of eyeballed it so that it looked like I would get in there pretty far without creating issues. I think I'm gonna come in just a little bit further. If you, I'll make a drawing to show this, but basically I want the cutting edge to be kind of as square as I can get it at the bottom of the slot, and so I think if I feed in a little bit further, the bottom of that cut will be a little bit squarer. Alright. That looks great. So this facilitates the pinching action of the seat collar, and so you need this slot in here, or else you're just pinching a tube. You can't get any, you can't get any pinch. But there's particular characteristics we want. We want it wide enough of a slot that it doesn't bottom out on itself. This is plenty wide. And then at the bottom of the slot, we got these sharp square corners. You know, I explained that saw that I have has square corners. I wish I had rounded corners. I'm going to come in there with this little round file that I have, and this takes a while. And I'm going to just like, I'm gonna work on that until I have a nice smooth round bottom there. You could pre-drill a hole and then work up to the hole, but you need to be really careful that it stays centered, or else you have a really nice straight line leading up to a hole and they're off center of each other. That looks stupid. So I'm just gonna round this out by hand. It'll take a little while, and then I'm also gonna kind of deburr the edge, but it makes a nice slot. And if you had a full radius cutter, it would really be the cat's pajamas or whatever. It'd be sweet. So I should explain, the reason that I want the bottom of this to be rounded is not for aesthetic. If you have a sharp square corner in an area where you're pinching and the tube is flexing and you have the strain of the seat post with the rider's weight on it, this can become what's called like a stress riser, right? Like if the frame is gonna crack anywhere, it would crack at like these, the little sharp point there is a perfect spot for where that can start to happen. Now, this is pretty meaty. We used what's called a seat tube sleeve or a seat collar, and so I mean this is pretty thick here. I don't know if it's as likely to crack, but you see this actually as a somewhat common failure mode on like road bikes and stuff, especially in the old school when you're building steel road bikes and you had a lug up here. The lug was like the socket joint fitting. It made things stronger, it made it easy to build, and then that reinforced the zone. And then when you started to see, fillet brazing and TIG welding, people were sometimes using tubes that were designed for lugs. They weren't that thick up at the top, and you'd weld or braze them, and you'd have, all the stress of that joint and the clamp mechanism, and they could crack and fail there. And you see that sometimes a crack will propagate out of the bottom of the slot. And so I've noticed, Eric Noren from Peacock Groove will actually always braze on a stainless steel washer right there to reinforce it. I'm not sure if I'm going to do that. I'm kind of close to the weld here now anyway, but you could do that. Certainly it's not a bad idea. Because this is so thick, I think, fingers crossed, it's going to be fine, but I want to round out the bottom of it, because if it's nice and rounded, stresses that come into that zone and, forces and stuff, they're not going to have this one spot where they want to, kind of fissure off into a crack or whatever. I don't know. That's just my intuitive, logical sense of it. You may be thinking to yourself, Joe, you totally forgot about the bottom bracket shell. That needs prep, and you would be totally right to say that. I'm not sure that I'm actually going to show that on the series, and there's a number of reasons that go into that. So if you remember in the design videos, I was talking about using T47 as a bottom bracket standard for this, and there were different competing considerations in my mind. I believe that T47 is probably the best standard that you can put on a bike like this as a small-scale frame builder. But I went with, I know you guys all hate this, I went with press fit. I went with a, I forget what, it's been so long since I thought about it. It's the common, you know, like press fit standard, the Shimano one. Anyhow, I went with that for a number of reasons. What I wanted out of my bottom bracket shell was a larger diameter so that I'd have better weld, like more area for welding these tubes where they overlap. And so you can do that with a larger diameter tube. Where an English thread bottom bracket shell is 1.5 inch diameter, this one is 1 3/4. T47 is 2 inch. So T47 would be great. The reason that I didn't go with T47 is the taps are crazy expensive. They're like $300 or something for a set of taps, last I looked. And people have had some issues with them too, especially titanium builders. Sometimes they break. So if I was building many frames at all, I'd just go straight to that. But also, I'm interested in press fit, and people have given me a lot of shit for this, but like, I'm curious about how bad is press fit, right? Like BB30, you push the bearings directly into the frame. That was a nightmare. And then, you know, you have ones where you push in like a plastic or a composite or an aluminum cup, and people tend to agree that that's a nightmare too. But I'm curious about that because there's different narratives or there's different explanations for why press fit sucks. And some people say bearings should have threads. Other people say, no, it's an issue that, like, you know, the bike industry at large is producing to a price point, and they can't maintain the tolerances that they need to, and Shimano and SRAM don't even publish the specific spec for like what the tolerance is on the frickin' bore. And then you have like you know, teenagers a lot of times working in a bike shop for like nearly minimum wage. They don't have the training, they don't have the tools, and so they just kind of cram stuff together. And for all these reasons combined, in the real world, press fit a lot of times gives people a very bad experience. It creaks, you need special tools to work on it, and so for the end user, the amateur, and the professional, a lot of times a threaded bottom bracket shell works really well, and it's convenient, right? But I didn't want to buy those taps because I'm a cheapskate and I don't build a lot of frames, and I'm just curious, like, if I actually do it right, how bad is it going to be? And so there is, I think, a SRAM PDF that outlines what the fit is, what the diameter is supposed to be for their bottom bracket shells for this bottom bracket standard. And so I'm going to hit that. And the reason that I'm not going to show that on camera is because I don't have the cutters today. It's basically the same process as the head tube. I had been considering doing it with setting it up on my milling machine and using a boring bar and getting the diameter right, but I just think about like the amount of time that would take to get it right, and the possibility of like boring it oversized or getting chatter or something. Like, I just don't know that I want to screw around with that. I think I'm going to buy the cutters, see if any frame builders have them secondhand. But anyhow, that's not really that relevant to you guys because it's pretty much the same exact process as the head tube. It's a reaming and a facing operation, and also everybody hates press fit and nobody wants to build their bike with press fit. Apparently I'm the only one. Me and Sean from Vertigo Cycles and Peter Verdone and like 2 other people are the only people on the planet who apparently give it any credit. And so I'm not even sure if it's good. It's probably not. I just want to try it. I'm curious, you know, I want to try it. So that's why I'm not covering this. I will drill a hole in the bottom bracket, and that's so that any moisture that gets into the frame through like condensation, it can drip right out the bottom. And I would always do that on a bike. I would never not do that. I also think it's important, the one that goes between the bottom of the seat tube into the bottom bracket shell. That's very important. If you don't do this hole down here, you will eventually see porosity, rust from the inside out, making holes in the bottom part of the seat tube. But similarly, I also want to drill a hole here. But other than machining the bottom bracket shell and putting in that hole, and I need to do the routing for the seat thing, we're ready to get into paint.